Good morning, everybody. Welcome to class this morning. Thank you for joining me, whether you're watching this live or you're watching it recorded. I always appreciate you all tuning in and watching and getting engaged and involved in the class material. So today, since we have an extension of what we were doing last week, we're going to be expecting a bit of a shorter live stream today. I also have a hard out today at around 40, so I want to pay close attention to the time. Don't want to really go over around 50 minutes today. I don't know that we'll take that long, but I don't want to go over that amount of time because I do have an important meeting that I have to be in at 11 o'clock. That's about providing new services and new technologies for all of you. So there's that. But while we're getting started today, I just want to make an announcement. And that's about next week. Next week, there won't be any live streams because next week here on the campus of Cleveland Community College, it is spring break. And the way I like to handle that with my online classes is that, I think you should have spring break too, right? Like if, all the seated classes get to have a spring break, I think you should be able to have a spring break too. So I like to give you all the option of taking the week off for spring break on spring break week, which is next week. So there won't be any live streams. You'll have noticed in the module that the next module, Module 8, has some additional time built into it that is for, the spring break week and being able to take the break. But, if you want to kind of get ahead or start reading and working on stuff, you're welcome to do that as well. It'd also be a good time if any of you are, kind of running behind a little bit to get caught up on some stuff next week with spring break. But today we're finishing up looking at loops. We're going to go back and we're going to refresh what we looked at with loops last time. And we're going to talk about the do-while loop, which is a bit of a different sort of approach to a loop. And time permitting, we might have some other stuff that we're going to look at today as well. That all just depends on time. But I want to go back and refresh what we were talking about last week. I want to talk about the do-while loop, and I want to do a fully complete program with you all today. So that might take all of our time. But before we get to talking about the do-while loop, what I'd like to do is I'd like to go back and I'd like to refresh and recap what we did last week with the while loop and the for loop. So last week we talked about two different types of loops. We talked about our while loop and we talked about our for loop, and we talked about the flows of execution for both of these types of loops. And we have this understanding that both of these types of loops work very similarly. One of the things that we said last week was really the for loop evolved from the while loop and how we, included all of the same stuff in our while loop time and time and time again. So if we approach some code here, and we're writing this the way that we want to write it, we were looking at our for loops and our while loops, and what we'll do is I'll write ourselves a couple new methods that will just do the loops that we learned last week. So I'll write one for a while loop and one for a for loop. And then we'll save this and do one for our do-while loop. And we'll talk about the differences when we get to that. So we'll make this a public void loop. Or a public void method. And we'll call it... what should we call it? Let's call it while example. And this will be for our while loop. And so what we'll do here is we'll just do like a little counting situation. We'll count 1 to 10. Just so we can have this proof of concept for the different ways we write our loops. And we said that, in general, what we do with loops is we use loops to execute sequences or expressions over and over and over again. And they give us more flexibility and they're easier to use than recursion, which we've done previously. So what we need for a while loop is we need some kind of counter variable. So we'll make an integer variable of x here. We'll set it equal to 1. And this will kind of be the counter variable that kind of moves or helps to move our loop forward. Because when we're working with a while loop, we're evaluating a condition, right? And that's what we put in our while loop is the condition that we are evaluating. And then we are moving some kind of iterator or counter variable toward the condition in order to break it. So we break our loop, right? So we could also say that while x is less than or equal to 10. So while x is less than or equal to 10, we have our curly braces to encapsulate the code that's part of our while loop. And what we'll do is we'll just system dot out dot print line the value of x, and then we need to take that x variable and move it in a direction to break our condition. So since we're going up to 10, we'll add 1 and increment the value of x. Just like that. And so this gets us exactly what we want. This will count up from 1 to 10, and it'll be the thing that we want to do with our while loop. So we have this counter variable or iterator variable, we have this condition, and we have this expression that moves our variable toward our condition. So if we invoke or call this method inside of our main method, while underscore example, we can see this in action. Now this is a non-static method here that we've written in, and we're writing it inside of our main method, which is a static method, so we need to use an object here. So we'll just write a new main object, main O equals new main, and we can use that to call our function. So now if we run this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Iterates through everything exactly the way that we expected it. And one of the things that we said that we do, right, is that, we do this kind of structure so many times where we have this sort of counter variable, we have this sort of condition, and we have this sort of incrementation or decrementation that moves us closer to breaking our condition. We have this so many times that we essentially decided, we want to write this as a shorthand. So let's come up with a, let's essentially come up with a for loop to do that. So let's write ourselves another method for our for loop. And we'll do this the same way. Public void for underscore example. And so in this instance, we can skip this variable declaration because we can do it all within our for loop. For x int x equals 1, x is less than or equal to 10, and x plus plus. So what we see here, again, is just all of these things that had been done previously in our while loop, just kind of put into a shorthand, right? Like we can see here, we have, our variable declaration for our counter or incrementer variable. We have our condition, and we have our incrementation. Now, the one difference between our while variable here versus our looping iterator variable here is that the x in my for loop example is scoped for that for loop. So if I referenced x outside of the for loop anywhere here, like down here, it's not going to have any idea what x is in this context if I were to run this, because that x is scoped inside of that for loop. So I could technically use a variable with the same name outside of a loop and inside of a loop, like inside of a for loop, and it not cause any conflict, which is kind of weird. So we're just going to want to pay attention to that and make sure that we're not duplicating any efforts, because that's something that could be confusing. But in this instance, we're just going to write our same system.out.println here. And we're going to write it with x, so each time it goes through the iteration, we get whatever the iterator variable is on that particular iteration. So this code here and this code here is the exact same code for incrementing this count to 10 situation. So if I want to test this one out, I can remove that code there, use my object o.for example. So now that while example is gone, that for example is in its place, but we'll see it with the exact same output of code. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so as we progress and as we do more things, of course, these loops are going to become more and more important to what we do. But that's the while loop and the for loop that we created last week. And so from here, we can kind of pick up something new, which is a different type of loop. It's our do while loop. But let's run back and explain the flow of execution just one more time of the loops that we just saw before we get into our do while loop, so that we can understand what makes the do while loop different. So when we work with a while loop or we work with a for loop, the initializer runs once at the very beginning of the loop. So we get that loop started. It checks the condition each time through the loop at the top of the loop. So if that condition is true, it executes the code that's inside of the curly braces for said loop. If it's not true, it just moves on to the next thing. And at the end of each iteration, we go back up to the top of the loop, we check the condition, and we run it again and again and again. In that same way. Now, we have this other type of loop that we could use. It's called the do while loop. And with the do while loop, this allows us to kind of flip the flow of execution for our loop. Instead of checking the condition before our loop starts, it checks the condition after our loop finishes. So we can also call this a post-test loop or an after-test loop. Because we're executing that code, we're executing the code in the curly braces before we check the condition. The condition is checked after it iterates through the code that belongs to the loop. And we'll see this kind of in contrast with those examples that we've already done here. Now I have a couple examples of code here that we can kind of run through and look at. This is a standard do-while loop. This is kind of an interesting little loop. It's a randomizer to find points that are inside of a circle. So you're trying to find a point in a circle, and then you're checking it to see whether it's inside of the circle or outside of the circle. But in order to check to see where the point is, we have to first generate the point. In this instance, we're generating random points. So we have an x value, a value that would go on our x-axis. And we're saying 2.0 times math.random. So remember that math.random is any number from 0 to 1, so it's a floating point number. So 0.1, 0.2, 0.3, to as far out as you can go, which is why we're multiplying it by 2 here, so that we can get a value that is between 0 and 2. Because if it gives you the random value of 0, 0 times 2 is 0. And then we're going to take that value and subtract 1 from it. So that gets us a low value of -1 on the x, which would be this position here. So that position is -1, 0. So it could get you anything between -1 and 1. Then we do the same thing for our y values. So that's going to be 0 and 1, 0 and -1. So this allows us to generate any point that's kind of that would be kind of encapsulated in this square. Because we could get anywhere from -1x to -1y, which is going to be the corner here. +1x to -1i is going to be this lower right-hand corner. 1, 1's the upper right-hand corner, and -1, 1 is the upper left-hand corner. So we can put a point anywhere within this box, and then we want to determine whether this item is inside of the circle or if it's outside of the circle. And so we generate this point, and then we check the condition. While math.square root x times x, or x squared plus y squared, is greater than 1. And so that's just some calculations that help us cover in this area. So if it's greater than 1, if we have a point that's not inside of our circle, it's going to jump back up to the top and try again. But if we get a point that evaluates this to less than 1, we know that that point's going to be inside of our circle, and that's what's going to be the break point for our loop. So this is kind of a complicated example because it's, a bit of a higher mathematical sort of example. Not really but even though it would be like a common type of use case for a do while loop, if you haven't done a whole lot of graphing algebra or geometry in this sort of way, this might cause you some issues. So let's look at another example here and try to make some more sense of it that way. And this will be something that we could do with our do while loop. In this instance, we're using it to check a variable. Or we're actually using it to do some input validation. Right? So we looked briefly at input validation before. This is another input validation method that allows us to do to check an input to see if it is a number. Right, so what we do is we start with our scanner input, and we have a Boolean variable that we've named OK. And we're just doing some input validation with this, and we're going to say, well, system.out.print, enter a number. If in.has next double, then OK will remain true, else OK will remain false. And it'll take our in.next as a string. And print out that that particular thing is not a number. And so as long as not OK, as long as OK is false, we'll keep running through this loop until we get it evaluated to true. And that's going to print this out, or take our in as next double. And so we'll do this example, or we'll do this as part of our big example that we do a little bit later. What I'd like to do is I'd like to just kind of take our while loop or our do while loop rather, and put it in comparison with our while loops and our for loops, just so we can see how it's different here. So let us go back to our REPL. And let's write ourselves a do while loop here to go along with our while and for loops. So we're going to have a public void do underscore while. And we're going to first tell our code what to do. And so in this case, the do is going to be system.out.println x. So, well, that's going to be our do. So this sort of kind of tells us, well, this is a little bit off because we don't have an x here yet. So we have to, our do while loop is going to be more similar to our regular while loop. So we have to create this counter variable or iterator variable before we get into actually making the loop. So this is going to be int x equals 1. But now we also need to progress that variable. So we'll say x plus plus. And it's only at this point where we'll check our while condition. So with our do condition, or our do expression, we also have to have a while expression. While x is less than or equal to 10. Just like that. But let's talk about the difference here, right? And kind of make this a little more clear. And let's think about it in terms of flow of execution. So when we consider our old while loops and for loops, we saw it go 1 to 10. It evaluates the condition and then runs the number. Well, in this case, it's running my code and then checking the condition. So on the first iteration, we're going to get 1, and then it's going to go x plus plus. So at this point, x is 2. So x turns into 2 before it evaluates the condition. Now 2 is less than or equal to 10, so we're going to jump up to the top. We'll print out 2, then we'll add 1, and we get 3. We jump back up to the top because 3 is less than or equal to 10. This is a 4, so 4 is less than or equal to 10. We jump back up to the top. We print our 4. It becomes a 5. 5 is less than or equal to 10. So on and so forth. So if we run this, let's just see what happens with our code. We can run our do while example, do underscore while, and see the output of it. It's the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now where this gets interesting is when we do something like this, where we take out that equal sign. Let's see what happens then. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same thing. But let's take this a step further and do this. Let's change where we iterate our variable. Put it there. 2, 3, 4, 5, 6, 7, 8, 9, 10. We actually get a 10, even though we know from our conditional practice in the past that when we say less than 10, we mean 9 and below. Right? But we get a 10 here, and that's because it's not checking the condition until after it runs this code. So this x becomes 10 before it checks this condition. And then it says, oh, 10 is not less than 10. 10 is equal to 10. So I don't need to run the code anymore. So we could change this up and start at 0 and use a less than condition here and get a sequence of 1 to 10. So now we have 3 different loops here. All of them count from 1 to 10 for us. And all of them do so in a very different way. Now I'll give you this file when I put out the recording, so you can see all these examples together. What I'd like to do now is I'd like to do a bit of a longer program, just so we can kind of make a bit more sense of these sorts of things in context. So this program that I'm about to do typically goes over better when I'm doing CCP classes at the high schools. Because a lot of those, when I go to them, they have some sort of door code to get into ancillary doors around the school. Like, you have to type in some kind of six-digit code or something like that to be able to get into a door to go between classes where you have to go outside to get to them. But we can kind of think of this in terms of a business or any other kind of organization that would need to secure doors, change the codes to these doors on a regular basis, and needs like a random number generator in order to be able to do that. So what we're going to do here is we're going to build a random door code program. Let's wait on REPL here because it's being just a little bit slow. So here's what I'm going to need to be able to do in order to get these door codes. One, I'm going to need to figure out how many weeks of door codes or how many days of door codes, just depending on, how often your organization sort of changes these codes. How often they do that. I'll need to, and there we'll write a do while loop to make sure that we get an integer output for that. And then we'll need to write some kind of looping variable. We'll probably, or not variable, some kind of loop, some kind of looping method rather, that will take and generate a new unique random door code for each of the weeks that our user indicates that they want to create a door code for. So let's do that, shall we? Relatively simple problem, but a good, realistic sort of use case for this nonetheless. So let's start off with this input method. So we want to get an input from our user. We're going to want it to be an integer for a set number of weeks, because you can't have you can have part of a week, but we don't want to do that for our purposes. And we're going to do some input validation to make sure that our user enters in an integer for this program. So what we'll start off doing is we'll import scanner, import java.util.scanner, and we'll put our scanner invocation at the class level. So public final scanner in equals new scanner system.in. So now we have our scanner initialized at the class level. We can use this same scanner in multiple methods. We're only going to need to use it in one method for our purposes here, but it is, a good best practice. And so we can start to write this get input function, and let's make it a value function, right? So let's go public, or actually it's an input. We should do it private, int get input. And we can give it maybe a string argument of a message. Now we'll go ahead and finish our stub and say return 0 for the time being. So we have since we're using an integer value method here, we're going to go ahead and complete that stub just so we can, we can kind of print this out and test it. Let's see, this is a private value method, so we'll need to use an object, name of the class, our object name equals new name of the class. So then this can be o.get input and we have to give it some sort of string message. We'll just put a little test message in there for the time being because we're not using that yet. This is just so we can test this and make sure that the stub that we wrote here works. So if I run this, I get 0. That's exactly what I should expect to get. So now we'll get our integer and we will use some input validation for it. We'll create a Boolean variable that we will call is number, something like that. That way we can check, just, we can just use a nice little name there. And we'll say do system.out.print message if if let's see, I think I can say this dot in dot has next int we'll set is number to true. Else we will set is number to false. Create a string variable, string word equals in.next. And system.error.println word concatenate is not a valid entry. So that's our do, that's our input validation checking. We're going to check to see if it has an integer. If it does, then we're good. If it doesn't, we need to do again. So we'll do this while not is number. Or I have that in the wrong place there. A little confusing with my all my curly braces that we have running around here. But that's the way that programming is sometimes. My while goes here. And so if that is the case, we'll have an int variable and we'll call it value, and we'll set that equal to this dot in dot next int, and then we'll return value. So now we have a bit of input validation using our do while loop that we learned today. So as long as is number is not a thing, as long as is number is false, it'll keep asking us for a new thing. So let's change our message here to enter number of weeks to generate. We'll go ahead and use the message that we're going to use for our program and just give this a little test before we move on to the generation code. So let's run this. So that looks good. If we enter in something that's not a number, like T, we should get T is not a valid entry, enter number of weeks to generate. And as many things that are not a number that we enter. If it's a decimal number, that's not a valid entry. What we want is an integer. So if we enter something like 12, we get 12 back. So now we see that our input validation is working wonderfully. Perfect. That's exactly what we would expect from it. So now that we have that, we can move on and we can write what actually generates our random numbers. So let's clear this out. So this is good. This is tested and been found good. So let us create a, we'll make this a public void generate numbers. And we're going to need that integer that we get from here, right, from our getInput function. So we're going to need to have an argument here of int weeks. Now we said we want to generate a random number. So we will get to that in just a moment. Or you know what, let's go ahead and do it. Because we'll need to do the things that you've done before to generate random numbers. We'll have to import our random class, which is up here at the top. So import java.util.random. We'll need to create a random generator here at the class level. Public final random r equals new random. And so now in our generate numbers function here, we can deal with that. So we'll do this with a for loop because that's our shorthand. So for int x equals, we can start with 0 or we can start with 1. If we start with 1, we want to use a less than or equal to comparison operator. If we start with 0, we want to use a less than comparison operator. But I want to start with 1 because I want to do a little something else with this value. Because I also want to display the week number along with the random number. Right? So we can say week 1, week 2, week 3, week 4, so on and so forth. So since we're starting with 1, we're going to have to use our less than or equal to comparative operator. So x is going to be less than or equal to weeks, which is the number that we're pulling in via our argument. X plus plus. We will system.out.print week x colon, and then we'll generate and print a random number. So system.out.print this.r.next int, and we want everything that is from 1000000 to 9999999. So we'll start out with 900,000. So that's going to give us a random integer between 1 and 900,000. But then, or 1 in 899,999, because remember, it goes up to but does not include that last number. So then I'll take this random number and I'll add 100,000 to it to ensure that my numbers are 6 digits, because that's going to start me at 100,000 and take me up to 999,999. So this will give me, so my random number code here on its own will give me anything from 0 to 899,999. And then if I add 100,000 to it, that ensures I have a 6-digit number from 100,000 to 999,999. So each time through my loop, for each week, it'll tell me it'll print out the week number, and it'll print out a random 6-digit number that I can use for a door code, which leaves me with implementation. So this is going to probably put us right to the end. So all I have to do now is just kind of put this all together. Let's add a title to this program. System.out.println. I'm back in main now, if you didn't notice. We'll call this random door code generator. We will invoke our generate numbers. So that's going to be o.generate numbers. And in our argument value, that's going to be o.get input with a string message of enter number of weeks to generate. Let's see here. We need to put a semicolon here. Got a semicolon there. And this is all we need for our code. So now we can watch this work. So when we run this, we get random door code generator, we get our title, we get enter number of weeks to generate. If we enter in something that is not an integer, we get that it's an invalid entry using our do while loop input validation. If we enter something that is an integer, like 8, we should get 8 weeks of random 6-digit numbers, like so. Now everything here is on the same line, so we need to fix that really quickly and change this print here to print line, and that should fix that up for us. So enter random number of weeks to generate, 8. We get 8 weeks with 8 random 6-digit numbers. Perfect. And we didn't have to generate something for each specific week. We let our loops do that for us. And I can do this as many times as I want. Like if I'm doing it with schools, there are typically 32-ish weeks in a school year. So I can just generate the entire year all at once and have a random 6-digit number for every school year week. So I'll give this to you also when I put out the recording. So you'll have this and the previous example. But this is where we'll stop. I'll probably also put out another video about string manipulation either later in this week or maybe as a part of our spring break week off. I'll just put that out for you then, because we can kind of go hand in hand with string manipulation and loops. But we've hit about the 50-minute mark and we're approaching my hard out. So I will hang out in the chat for a couple minutes just in case anybody has any questions. If you're watching this on the recording and you have any questions, please feel free to email me. Remember that next week we won't be having a live stream because it'll be spring break. Take the time off if you'd like. If you need to catch up, it'd be a good time to use to catch up. But that's all that I have for you for today. Thank you for watching, and we'll see you next time.